Hi, everyone. Thanks for attending the webinar. My name is Pasquale Napolitano. I'm the Stormwater Maintenance Specialist here at Hydro International. I'm going to talk a little bit here about stormwater maintenance myths. Okay, so who is this webinar for? You. It's for everyone, really. If you're a specifying engineer, if you work in the municipality doing public works, a city, state, county, watershed, if you're a regulatory or approval agency, this can be for you. And finally, if you're a business or property owner or manager, there's something you can get out of this as well. And you'll see some photos here at the bottom. These are of, on the left side, a failing bioretention system, and on the right, a stormwater pond. So I'm going to be using a lot of photos from the field to sort of inform what we're talking about here. These are just a couple here that I've put in, but the other photos we'll be using will be specific to the points that we're going to be making. So who am I? Again, my name is Pasquale Napolitano, Stormwater Maintenance Specialist at Hydro International. Past few years, I've been doing a variation of maintenance and why maintenance isn't occurring, or what we can do better to increase maintenance compliance at different speaking events and presenting papers, and I'll be continuing to do that this year. I work at Hydro International. As the name suggests, the company is international. We have offices all over the world. In fact, this map is recently out of date, but I work specifically in our stormwater division here in Portland, Maine, and cover North American maintenance. What do we do? Hydro International does a lot of things. If it's water related, CSO, wastewater, stormwater, hydrometry, a little bit of everything really when it comes to water. But specific to stormwater, we have plus 30 years of experience with BMPs. We have an in-house hydraulics lab. We have thousands of stormwater separator and filter installations around the world. We're also a maintenance and service provider. So because of that, we have a pretty holistic view of the post-construction life of a stormwater BMP, because we're working with regulatory and approval agencies for new products. We're working with local, state, county engineers, private engineering firms, contractors, and as well as business owners who have BMPs after a site is completed. So this unique perspective is what informs what we're sharing with you today. So why are we talking about this though? The simple fact is that the majority of stormwater BMPs do not receive routine inspections and maintenance. Now, that's sort of a tacitly understood thing by, I think, most people in the industry, but to back that up a bit, we've looked at our own stormwater filter installations and can say that less than 10% of these systems are actually having their filters changed at regular intervals. So we can say that about less than 10% of systems are being maintained regularly. But truthfully, that number is closer to 5% than 10, but the truth is it's not the majority. So what is the result of systems not being inspected and maintained? Structures fail. Not only do they fail, it becomes something that doesn't get noticed. And to kind of highlight that point, here are some photos here of some inlets, catch basins that are completely filled with material. And all three of these examples are of locations that receive either quarterly or biannual sweepings and cleanings. So you see it doesn't take long for material to fill up and for water not to be able to pass. And the point of that, to show this, is to say that all of you come from different backgrounds, but anyone who's involved in approving manufactured treatment devices or in specifying different types of BMPs for a site, installing those, maintaining those after the fact, everyone who's involved, all the work that we all do, it's all wasted within 12 to 24 months after a site is completed if there's no inspections or maintenance happening on any of these devices. So with that, to hopefully to combat that, I'm going to address some common myths and try to give you a little bit more information about those and how you can better approach those when you see those. So these maintenance myths are The first one, that oversizing water quality units can extend the maintenance interval, that some treatment systems can go years without service, that self-cleaning systems don't need to be maintained, that some manufactured treatment systems can't be cleaned, and that manufactured systems should be sized based on their sump depth, and that some manufactured filters do not require new media, and finally, that low impact development is cost effective or more visible to identify failures. So these are the main myths we'll be going over, and I have a quick poll I wanted to bring up with everyone just to see how many of you have heard these before. So just give everyone a few minutes to do the poll. I'll give everyone about 10 more seconds. Okay, so hopefully you can see the results. It seems that the majority of you have heard at least some of these myths. So good. So hopefully I can shed a little bit of light on some of this based on the presentation here. So now we'll get into the first maintenance myth. And that is that it is better to oversize treatment systems so they can go longer without maintenance. And just a couple photos here of an 8-foot and a 10-foot diameter separator structure being installed. Now, what's the fact of oversizing water quality units to extend maintenance? The fact is that the larger the system, actually the more difficult and expensive it is to maintain. Now, this is particularly true if you wait several years to service the structure. Other things that can affect this, cold weather climates with deep sumps, locations near ports and harbors that may have deep sumps, make this a little bit more difficult. And then additionally, in cold weather areas that receive a lot of snowfall, you may have road sand that accumulates. So in the middle photo there, you can see road sand from the winter accumulating and going into the drainage lines. What you have on the left is a hydrodynamic separator, which is completely covered with material from not being cleaned. You can't see any of the internal components. And then on the far right, that is actually just a standard catch basin. But what you can't probably tell from the photo, but that is 7 feet of material that we pulled from that one catch basin. There were 40 of those basins on site. Some of them had 7 feet, some had 5, 6 feet. So, making a sump deeper or a system larger doesn't mean that you have less material going in them. So what are some recommendations to this? Well, first of all, the thought is that the larger the system, usually they cost more. So there's a higher capital cost to construction there. Now, you can also be passing on higher maintenance costs because of that as well. As I mentioned, if a system is already in a difficult place with a deeper sump, that's going to cost more to maintain. Now, if you're doing this regularly, it's going to cost more if you installed a bigger system. Now, if you do it every few years, it's going to be even worse because it's harder to remove the material from the sump itself. So the way that usually gets tackled is, as you can see in the photos here, you fluidize the sump with the power wash that come on with vacuum trucks. You use that PSI to wash and fluidize the material in the sump, and then you can pump it out easier. The two examples there, one is a stormwater separator system and one's a standard catch basin. So this is pretty universal for catch basins and structures to have to power wash them to get the material out. So if you made a larger system and a deeper system that receives more material than you anticipated, you can see how this can become problematic. And again, as I mentioned, colder weather, there's other conditions here. But one of the things I will mention too is that new construction, if a site or a BMP hasn't been cleaned after construction, a lot of that material can form like cement in the sump of the system. Road sand can create the same thing. And when that happens, it becomes harder to clean the system. And even when you're trying to test for how much sediment is accumulated, you may hit a false floor of the sump and not even know how much is in there because it's hardened like cement. So with that, we'll go into the next myth, which is some systems can go years without maintenance. Now, to highlight this, I've just included a few, again, stormwater manufactured treatment devices, some separators. On the left, you have a structure that has captured hydrocarbons. In the middle, you have a structure that has received fats, oil, and grease from a restaurant and has blinded and binded up the system. And on the far right, you have a separator system that's completely full of trash. So the fact is that the only way to determine maintenance intervals, it's with regular inspections. So when you do that though, you can't just pop a manhole lid and say, okay, we've looked at it, we know the condition. You need to actually look at the water levels and the sediment levels to understand what's happening in the structure. Now, in the case of many manufactured treatment devices, some LID systems, and certainly in most underground detention systems, this is going to require confined space entry. So you will actually have to send someone into the structure to get a proper read on the condition of things. For manufactured treatment filters, this means physically inspecting the media condition. You know, if this is a membrane filter, if this is a media, a cartridge, regardless, you're not going to know unless you actually inspect the filter component itself. So you do have to enter and physically inspect. And there's some examples here on the left of a membrane media system. Two in the middle are media pack systems showing confined space entry, and the far right is the cartridge system. So you do need to actually look at the systems to know how long they can go without maintenance. It's not just a given. So the recommendations, you know, inspect 6 months in the first year. That's sort of a given. You should do it once a year thereafter. This is something that gets sort of repeated ad nauseum, and it's on a lot of forms. So it can't be anything new that I'm telling you here. But the truth is that, again, if you don't actually look at these, you won't know. And we find that when we go out into the field, when we do actually look at, say, filter components or underground detention systems, it's very rare that we look at them and say, well, everything's working fine. You know, we'll come back again in a year and, you know, see if it's ready then. Usually there's some work that needs to be done. So you do have to actually inspect these structures to know how long they can go without maintenance. And then based on a backlog of every 6 months or every quarter we've looked at this system can roughly go this. That can help you budget how much you think this will cost every year, or however you want to frame it, to know what you'll be spending on the maintenance cleanings. But I will say that in most scenarios, we find that annual cleanings as a sort of preventative maintenance is less expensive than waiting to clean the structures. Regardless of if this is underground detention or a separator or a filter system, waiting until the system is chock full of material is the worst thing you can possibly do. Because by doing that, you have a more expensive disposal, usually takes more time on site, it's a more arduous job, depending on where things are located, like such as on the side of a highway in one of these photos, can be more dangerous, and there's other things such as lane closures and things that you have to take into account. Another recommendation or thing I would point out is that depth of material is one of the measuring tools that everyone uses to say how much material is in the structure. Well, 5 inches of material in a 6-foot diameter stormwater separator is a totally different thing from 5 inches of material in a CMP detention structure. So here are some photos from the field. This is actually 7 inches of material that was spread across corrugated metal pipe system. And you can see from the photos, it's not an easy task to remove this. So keep in mind what you're looking at here. You can't just say, well, if there's X amount of inches on all structures, you should clean it. Every structure is different and should sort of be addressed that way. If you imagine how much underground detention you may have on a given site, you multiply that by 2, 3, 4, 5 inches, you can see how it's many tons or yards of material. One of the ways to mitigate this is if you have pre-treatment BMPs to say underground detention, cleaning those regularly should mitigate material getting into these systems and will make for less expensive annual costs or push off sort of more extensive cleanings of these underground detention structures. We'll jump into the next one, and that is the myth that self-cleaning systems, being that they are self-cleaning, don't need to be maintained, or slightly more reasonable stance, they don't need to be maintained as frequently as, say, other devices. And just the sort of photo slides I filled in here, it's a bit of a sliding scale from left to right. Again, these are hydrodynamic separators. On the far left, you have one that is completely filled with sediment that you can't even see the internals because it hasn't been cleaned. In the middle, you have one, this is actually 8 months after it was last cleaned. It's filled up with material again, which is good. It's capturing it, but it needs to be cleaned. And on the far right, you see one that is actually cleaned. These are all the same structure. It's a downstream defender, but I use the same structure to kind of show you a scale of how much material can get into a system. So what's the fact about systems that self-clean or can go longer because of that? Systems with self-cleaning mechanisms can extend maintenance cycles, but no system can go without maintenance indefinitely. So different technologies and features can help to extend maintenance cycles, certainly, but that doesn't mean that you can sort of kick the can down the road on maintenance indefinitely and get yourself years and years of no maintenance out of a structure. We find by going out into the field that that's not a reasonable expectation. Now, of course, every site and treatment area is different. So if you're talking about a cul-de-sac with 3 houses on it or a small elementary school, that's very different from a large mall or maybe a industrial business park. They see different types of pollutants. And so that will determine how much these structures are seeing and how often they need to be cleaned. And so the examples I've used below, the far left is a separator system that wasn't cleaned for years because it was actually covered up, and it had to be uncovered. It was paved over. The middle structure is another separator system, which is filled with material, and the screen needs to be cleaned. The whole system needs to be cleaned. And on the far right is a screen on a filtration system, and it's just showing that it's not trash and necessarily like oils and grease and things, but pine needles and grass clippings, pollen, things like that. Those can blind screens over time if you do absolutely nothing in terms of cleaning these structures. So yes, they can extend it, but that doesn't mean you don't have to clean it all. And an example I'll use again here, these are fats, oils, and grease inside a separator system, which has completely blinded everything up. So you also keep in mind that if you're not regularly looking at these structures, when something like this occurs, you may be none the wiser until it ends up downstream or things back up. So what are some recommendations to get around or to better deal or be informed about self-cleaning systems? Frankly, there's nothing that's going to eliminate the need for inspections and maintenance. It's really hopeful thinking. You may want to project, great, this is a low touch, low cost structure we want to install. Maybe a salesperson has told you, you don't need to worry about this for 5 years, 7 years, whatever it may be. These, again, based on being in the field, seeing these things, they're not realistic expectations. So what can you do about that? You need to understand the mechanics, understand what's being presented to you or what you're looking at for options for what you might want to install or what you already have installed, and ask questions. One question could be, what's the correlation between self-cleaning and bypass or washout? Everything's related. Nothing happens sort of in a vacuum. So if something is self-cleaning, does that mean that things are heading downstream? Is there another junction or something that stops that? How does that work? Are there tests or different agencies or authorities who will verify the nature of the extended maintenance cycle because of the feature of a device? If these devices are approved, those should be there, and then you can ask for that, and that should help inform how your system works. And one of the things is, are screens even the right application for what you're looking for? So, of course, some areas have total trash capture, and screens are very prevalent in those areas. But regardless of trash, screens, as I showed, were blind with leaves, other organics, grass clippings, etc. So In some scenarios, depending on what you're trying to treat or what you're trying to do, what your application of the property is, you may not need a screen device. So sort of pick the right device for what you need. In the photos I've included here on the top, that's a catch basin that has hypodermic needles in it. And the bottom is a drainage line that had hydrocarbons, had a diesel oil spill on it. And the point of showing those, yeah, they're sort of worst case scenarios, but they're actually more common than you think. And it doesn't matter how great a screen or how great a feature is to allow for cleaning, it's not going to stop these things from entering the waterways. And you know, some of the photos may be a little jarring, but again, we see these things, and we're trying to sort of share that with the overall stormwater community, so you can see that these things actually are happening. So I guess the closing point on this would be that despite self-cleaning, you still need to do maintenance. That's going to probably be the universal theme of this presentation. So this next myth is that some manufactured treatment systems can't be cleaned. I feel almost a little silly using this as one of the talking points, but the reason I include it is because it's actually something that we hear quite a bit, so it's worth trying to address and get in front of. And the photos I've just used here to illustrate it. This is a downstream defender. This is one of the devices that we manufacture. It's a hydrodynamic separator. You can see a standard Vector truck, either with 10 or 8-inch aluminum boom going down, standard cleaning. So let's look at the facts on systems not being able to be cleaned. So part of the regulatory acceptance for any treatment device is the review of the operations and maintenance of the device. So if a device in your area is approved by any major regulatory agency, think of your NJDEP, NJCATS, WDOE, your local or state Blue Book or DOT, if they're on there, then they can be cleaned. That's the simple answer. This is a very easy one, honestly. And what I've included here, on the left, you have a multi-bay separator system being cleaned. You have hydrodynamic separators here in the middle, and ones with screens on the far right, all being cleaned very easily with standard vacuum truck equipment. So the thoughts on this are, again, as I mentioned, manufactured treatment devices, if they're approved by a major agency such as these, they can be maintained. It's really that simple. This is a really easy one. This is something that's easily addressed. And in addition to that, any manufacturer of any treatment device can easily provide you with photos or videos, O&M manuals showing how the device is cleaned. So this is a very easy one. That's not to say that there aren't things that can't hinder maintenance. The point here is that manufactured treatment devices by themselves are maintained if they are approved. They can be maintained. Now, there are other circumstances which can make this more difficult. So that could be waiting too long in between services. Material builds up in the sumps, they're harder to clean. Inaccessible units due to distances or heights. So units that you can't park the truck and drop the boom directly over, you have to run a lot of flexible hose to get to, you lose suction power. Or heights, we see units placed in parking garages and you can't drive the truck in. So things like that, that can make maintenance more difficult, but that doesn't mean that the unit in and of itself can't be maintained. So an important point I would add to that is don't look to sacrifice treatment efficiency or the best available technology out of your options just because you have a perceived ease of maintenance. The idea being, well, product A or separator A is easier to clean. It doesn't perform as well as separator B. You know, don't let that inform your decision, because if it's approved, that shouldn't be a concern. So you can sort of wipe that off your mind and look just at the performance instead. And some of the photos I use here to inform this, there's a bit of a narrative here running across the bottom. This is where we had to park a truck, run quite a bit of flexible hose to get to the separator units. We got them down there, and then we set up a tripod to be able to then clean the devices. So was it difficult? Yes. Did it cost more than your normal cleaning? Yes. But I think any service team worth their salt is going to be able to clean pretty much any device. So that shouldn't be an issue. You just need to be aware that if you put something in a sort of a different location than where you have easy access, if you do that, it's just going to involve a little bit extra work and maybe extra money to clean those. And that's something you should budget for and plan for. And the final photo here is of a separator system that actually has to be accessed by running flexible hose into the basement of a building to access. It's a very unique application. We were able to clean it, but if I was talking to the engineer, to the contractor at the time when they were installing, I would try to dissuade them from putting one here. But it's there and we can clean it. So now the next myth, manufactured systems should be sized based on their sump depth. So manufactured treatment devices based on their sump depth, and this is just an installation of a 10-foot diameter structure being installed. So what's the fact here? Well, stormwater systems, they should actually be sized based on the water quality treatment, per the regulations, per what you're trying to remove. Don't look at the storage capacity. This kind of goes back to the very first myth we looked at. Doing that doesn't really do you any favors. And again, here I've used a hydrodynamic separator being a downstream defender. Here's one pre-service and then post-service. You sort of get an idea of how the system is. Now, what are some recommendations or thoughts about this myth that can help you sort of better confront it? It's pretty simple. Again, it's really to focus on, TSS, phosphorus, trash, hydrocarbons. What are you looking to remove? Those are what you should really be focusing on, not on the storage capacity or the sump depth. There are, again, circumstances, again, harbors and ports, cold weather climates that may have deeper sumps, and that's just a fact of life. But in general, if you aren't restricted by that, I wouldn't recommend adding extra sump depth if you don't need to, because it just makes it more difficult to clean these structures. And in adding that sump depth certainly does not decrease maintenance costs or requirements. So just as before, the recommendation would be to focus on approved devices, look at the best performance, look at the best available technology, make a decision based on that. Don't focus on the perceived ease of maintenance, because these perceptions are just perceptions. A lot of times systems are created differently. There's different technology. Do the best you can to have the manufacturers help compare them apples to apples for you, so you can get a better gauge of this across all the approved devices. Make your judgment based on that, based on removal efficiencies, etc. And what we have here again are manufactured treatment devices on the left here being maintained, being pumped out again by your standard vacuum truck. And then on the far right, it is a catch basin being cleaned out. So this myth is that some manufactured filters don't need new media, or they don't need new media for years. And the photos I've included here at the bottom are cartridge-based filters. There's a few different cartridge style filters out there, and these are ones that need service. So those are the photos I've included here. Now the fact about this is that stormwater filtration systems do require new media, and that's very simple. We go out in the field and we see this; they do require new media. There's nothing that's yet been developed that doesn't require media exchanges, and that's regardless of if it's membrane filters, if it's filter packs with engineered media, if they're cartridge filters with engineered media, etc. New filter media at some point is required. Again, every site is different, every drainage area is different. So light residential applications are very different from heavy commercial applications that we see about traffic. Your high-risk areas, truck stops or gas stations with gasoline or diesel fueling, convenience stores with trash coming out, car washes, those sorts of things. Those are very different from neighborhood applications or things like that, maybe near a pump station in a neighborhood. So, this statement isn't just a catch-all. This doesn't apply to everything. Filter life expectancy is based on the specific installation, the specific pollutants coming into that structure, and how frequently that happens. It's that simple. You can't make a claim, a universal claim on that. Every site will be different. So the only way you can really know that is, again, periodic inspections. And it sounds kind of bland and boring, and it's something that's just going to get repeated, but by inspecting, by physically looking at filtration media or membranes, etc., that's what's going to show you how long can this media last? You go at quarterly, 6-month, annual intervals, and then you have something to base this off of. It's not just a claim in a manual or on a website or from a salesperson. It's actually, we've been to this site, we've looked at it, we know every X amount of months, this is when you can expect this media to be replaced. And again, we've included here some cartridge media filters and the media packs on the far right, showing you this is from the upflow filter. On the far right, you can see the difference between clean or new and old media. So what are some recommendations to this? Just ask for third-party approval, showing that said filtration systems still effectively filter without exchanging media for years. Again, this is if it's filter media packs, engineered media, cartridges, membranes, etc. If these products are approved, there should be some sort of testing data that's been verified saying, yes, you can go X amount of time without needing to change filter media. But again, what you'll probably find in a lot of cases is that the language says something similar to every site is different, and it depends on what the site is seeing. So the photos I've included here, a membrane filter system, which has to be cinched and pulled out, and that's washed out. And at the bottom, again, this is the upflow filter. This is a filter component which a single person can lift out. So, all filters are different. They function differently. So being able to understand that will really inform your decision on things. Is this something that one person can handle? Does this need mechanical assistance? Things like that. And then, at the end of the day, pick the one that's best for you. Look at what the best available technology is and what you're trying to treat. But these are things that you should keep in the back of your mind. And these are more relevant to filter systems than probably other systems we would find. So when you compare costs, ask about the filter replacement costs. Even if you're being told repeatedly, you don't need to worry about this for 5 years, you don't need to worry about this for 3 years, ask for the cost, because that's not necessarily the case. You could have an oil spill on site. You could find that your particular site reacts differently to the pollutants that are coming into it than you thought it would. It's a new development, and now you have a whole lot of runoff that you were anticipating from something else or somewhere else, and you need to change it every year. So you should know those costs. Don't settle on I don't have to worry about this for a few years, therefore this is less. Go into it thinking I may have to replace this once a year, and if I do, what's the cost of that? And you can ask the manufacturer for this information, and they should be able to easily provide this for you. There's different things to keep in mind, though. Again, these are pretty specific to filtration systems. Filters involve a little bit more work to maintain. So things you may want to ask are, what's the duration of the service time? If you're not replacing media, but you're actually washing off membrane material, how long does that take? Is that a lot of time on site? Depending on what your property is that going to disrupt things? Are you not going to be able to access your parking lot? Or is it a egress that you can't have blocked off for long periods? These are things you may want to ask. If they do deliver new filters to media, say they're delivering big filter cartridges, how much space will that take up on site while you exchange out old cartridges for new ones? What's the lead time on replacements such as these? Things like that. These are good questions to ask. And as I mentioned before, can these filters be handled by a single individual? Can they pull them up? Do you need mechanical assistance to pull them up? Things like this. And if you do need mechanical assistance, can you get a truck or some sort of device close enough to the manhole to allow you to do that? And then finally, if filters are not replaced, what's the increased cost? So again, nothing sort of happens by itself. If you're using, say, a membrane filter, which commonly one of the things presented with membrane filters are that you don't need to replace the membranes, you can wash them off. Well, if you're washing them off, one of the questions you can ask is, when we wash this off, what do we do with the liquid waste? If you were to bring these above grade and try to wash them off, the waste will go everywhere, which you can't have. You try putting them in a 50-gallon trash can and rinse them off there. You're going to have to be constantly pumping that trash can while doing so. The membranes are likely taller than the trash can. Waste still goes everywhere. If you do it like the photo, you do it inside the structure, you need to be pumping while you're doing that so it doesn't go downstream. How much is that liquid waste? What does it cost to dispose of that liquid waste? Same thing with disposing of engineered media or cartridges. What does that cost? What can we anticipate for cost of disposal? The need for confined space entry, how much time on site? Things like this are all the types of questions you can ask about filter medias. And by doing this, comparing different filters, you'll have a better idea and you can better try to compare apples to apples. Everything's not the same, but these are the types of questions that help you identify that. So the next myth is that low impact development or green infrastructure is more cost effective than manufactured treatment devices and or more visible to identify failures because usually above ground. So, you know, I think the term green gets put around a lot of this, which is obviously appealing to people. And my recommendation would be that, you know, green is a color, but it doesn't necessarily mean that it's the right fit. As I've said kind of throughout this, choose what's the best option for what you're trying to install. You know, maybe some of you, depending on who's attending here, you may not have a choice, you may be stuck with something, but if you do have a choice, see what's best for you. That's what you should decide, not just flat out say, low impact development, green infrastructure, this is what we want to use. We don't want to use manufactured treatment devices. We only want to use this unless absolutely necessary. And the reason I say that is because looking at these photos here, you have an 18-month difference of a stormwater dry pond that has been mowed down on the far left. And within 18 months, you can see that it's overgrown here. This is from Google Earth. This is in the Northeast. So in, say, the Southeast or other areas of the country, you can imagine that there's not a harsh winter that kills off all the vegetation. So this growth would have happened even sooner. So just because you can see it doesn't mean you're seeing it. It's behind a box store. No one's looking at it. And therefore, it becomes overgrown and stops doing what it's supposed to do, and it fails. Just because it's not underground doesn't mean that it's actually being held accountable. So what's the fact here? Again, select the best available BMP or BMPs. Maybe there's a certain treatment train you can put in place. Green, you know, best management practices can very likely have lower capital costs, but they may and often do require more frequent routine services. So just take a detention basin, a dry pond, stormwater pond. Those need to be mowed frequently, and that costs money. Is it as much money as sending a vacuum truck to pump out a separator? No, but with the frequency, those numbers start to come close together. Now, if you opt not to mow out structures, then your pond can fail, and then that's a very expensive cost to fix. So, excuse me, some photos I've included here. You have an outlet control structure on the left, in a detention basin area. Saplings and things have overgrown it. Again, this is in the Northeast. This is 6 months after it had been mowed. Does not take long, and it can choke out the area that was designed to receive water. In the middle here, this is actually on a protected watershed, and you can see that there's an infiltration system with a tree planted. The tree's squashed, there's trash in it. There's a no spraying sign, but I mean, this device has been completely forgotten about. So the idea that this is low impact development, or this is something above grade or above ground, that this will be seen and therefore it's a better option than underground structures, it's a bit of a fallacy because that doesn't necessarily hold true. We find pictures like this one in the middle are very common to see, unfortunately. Just as common as they are to open a manhole and see a structure that's really filled with material. So, and the picture on the right here is a riprap channel, or what should be a riprap channel, into a bioretention area that, you know, the property owners have a team that goes and they mow, and they do that periodically, but they don't know what the stormwater structures are. They're a landscaping crew. So this has sat like this for a year, and then they had to have someone come in and have it fixed the right way. Other thoughts on that? You can really look at it by evaluating both capital costs and the routine preventative maintenance costs. So again, if you're looking at, is it cheaper or less expensive to put in a dry detention basin? Yes, but we have to mow every so often. How much does that cost? And then that's a preventative maintenance cost, okay. But then there's corrective maintenance costs as well. If you opt not to make sure that the inlets and the OCS are free of vegetation. So one of the things that tends to work in some areas is, you know, considering putting manufactured treatment devices to offset things like ponds, make the pond smaller, or help to extend the periods in between the pond needing extensive work. And the photos I've included here are before and after of a dry basin area, and you can see here that Even the fence was knocked down because no one knew what it was. They just assumed it was vegetation that was natural to the area, not that it was an actual BMP. And you can see, the amount that had to be flailed and removed and to get it back to its actual operating capacity. Again, this is in the Northeast. In other areas, this gets even worse, even quicker. So other thoughts and recommendations on that? Again, every site and drainage area is different. So if you come out of here, you're going to remember that every site is different. So you need to look at it that way. And also that you should inspect these systems often. That's the only way to know things. Those are the two takeaways. But some low impact development or manufactured treatment device BMPs, they could go beyond needing annual services. That's not to say they can't. But determining how long these intervals are costs money. You actually do need to inspect, and you need to see this. If you don't do that, then you're not going to know. You can't just go based on an assumption. That's how systems fail, and you end up having things such as these photos at the bottom, which become a very expensive fix. LID systems, again, just taking a dry detention basin as an example, almost constant service, pruning, weeding, removing invasive vegetation, mowing, mulching if it's a bioretention area, etc. If you don't do this, it's not uncommon, even for small detention ponds, to cost north of $10,000 to be flailed, reestablished, reseeded. Yes, maybe the capital costs are very low. If the system fails in 2 years because you've done absolutely nothing to it, it's stuck behind a supermarket that no one sees, it's not inexpensive to fix. So these are the types of things you may want to keep in your mind. What are the preventative maintenance costs annually, quarterly, etc.? And what if that doesn't happen? What are we looking at here for a cost to reestablish this structure? So some final thoughts on everything together would be that these myths aren't outright lies necessarily. A lot of them are sort of half-truths, or they lies of omission, or they keep out critical or crucial details. So, when you hear these common myths, it's to sort of kind of get your mind, and hopefully the images help plant a seed in your head to say, okay, when I hear this, maybe this is what I should think. So in that point, then to ask questions, put the onus of explain to me how this can go longer, explain to me why this can't be done or can't be cleaned. Put that back on whoever's telling you that it can be. And if it's a salesperson from a manufacturer, they should easily be able to produce costs and show you the procedures to do this. So it shouldn't be an issue, but asking them and hold them accountable to that. Because the more knowledge for you and them being asked what's better for everyone, that's the only way that this gets communicated down to the end owner user. Because the most common thing we find is that we get to the owner end user, the majority of them don't know what stormwater is, other than maybe some of them know it's a tax they get taxed on. They don't know they have a structure or structures. They don't know what they're supposed to do. They just know it's costing them money, and they're not happy about it. It's particularly frustrating for, I would say, homeowners associations who had no idea that they had structures and they had not budgeted for it. But the more everyone's communicating with each other, how long will the system last? What are its real capabilities? Not what the selling points are, but really what the actual capabilities are, will really benefit everyone. So to that point, think of who benefits, who's presenting this narrative to you, who's presenting you this myth or half-truth. Is it the manufacturer? Is it a sales rep? Are they trying to get their system installed? Their system might be perfectly fine and be a great alternative to what is being specified. It may not, and you won't know because they don't, they have their own objective here. Is it a contractor? They may have their own objective. System B is less expensive than System A, and then they can, make that money. But if that's in a case where then System B costs more to maintain, then the owner then ends up spending more throughout the lifespan of this BMP. So the contractor may have a different goal than what the owner has. The idea is to hopefully look at this and say, what are the lifetime costs here in terms of routine inspections, preventative maintenance, routine maintenance, corrective maintenance if need be. As I mentioned, we go out in the field a lot. We try to inspect systems before we do services on them to sort of identify what they need. It's about 1 to 5%, closer to 1% of inspected stormwater BMPs that we see. Only about 1 to 5% of them, we look at them and say, actually, this system's working fine, and we don't need to do anything for a period. Usually, there's something that needs to be done. So that's just based on going out in the field and seeing that. And the image I've included is, again, another trash racked control structure. There's not supposed to be any vegetation near it, and you can barely see it, and you wouldn't know it was there if you weren't looking for it. So if I could give you a checklist in closing for things you could look for, if you're a municipal engineer or a regulator, I'd start early, make provisions for a management plan, a compliance form. Usually during the permitting stages, this is really good because at permitting, people are they're already selling contracts and bonds and things. So this is a good time to say, owner or developer, you are obligated to maintain the structure, and you sign something with the local authority saying that you'll do that. These are good things in place. A lot of places do this very differently, but a lot of areas are doing this, and it seems to be working well to increase awareness and increase compliance. Maybe if you are a local authority, you want to decide, do we want owners to be in charge of inspecting their systems, or do we want a third-party inspection program? A third-party inspection program means that only an authorized stormwater professional can really see this. If you don't trust that business owners are capable of confined space entry and actually looking at a system, and you want it to be a third-party system, then make a short list and develop a resource where people can come and say, okay, here's a list of engineers and stormwater maintenance companies who can help you with that. So people know where to go. Sort of empower the owners, but be realistic about what the expectations are of what they can do. And then again, a minimal annual inspection requirement. Truthfully, it should be more than just annual, but things cost money. So annual should be the minimum guideline for that. Require photographs with inspections. We do see photographs. We see photo reports. We even see reports from engineering offices with no photos on, which just says X, Y, and Z structure needs to be clean. It's not a good way to do it. Photos really tell a complete picture. And not just that, but I would also mention, if you do put in a contract system in place at the time of permitting that holds an owner or developer accountable for post-construction maintenance, make part of that they have to renew the contract. Otherwise, they do it once and then no one does it ever again, which we see quite often. And you can help combat that by doing periodic independent audits and things like that. I know some areas, they do that for you. They take it out of your hand. The state may say, well, we're now going to audit your county and tell us who's actually complying. But doing that on your own skill can help too. For specifying engineers as a parting sort of checklist, I would say, ask questions, be specific. The last couple of myths I went over really kind of got into that a little bit more. Ask questions. Just keep on asking questions, and you should be able to get the answers pretty quickly, which will inform your decisions. Ask, will this structure work for this installation, and will it work for operational maintenance? Or is this just that this structure looks easy and cheap? What are the operational costs versus the capital costs? As I mentioned with the detention ponds, is this perceived ease of maintenance? Is it just perceived? Is this really an issue? Should you dictate what you're selecting for devices based upon what you find easy to maintain rather than what actually is treating the best area or preventing washout or bypass? And then again, who's responsible for the BMPs post-construction? Helping the owner be aware of this. If you're a specifying engineer working with the owner or developer, you're in a really key position where you can help that owner be aware of this before this happens. They're going to get binders upon binders of all the different things that are installed on site. And the stormwater is one of the first things that goes in, and it gets forgotten about. So helping them be aware of that's really key. And to that point, is the site being developed to be sold? Is this owner developer planning on operating this themselves? Are they going to lease it out? Knowing who's actually responsible for this is really key, because if not, everyone just sort of looks at each other, and it's really easy for time to pass that way while a system fails. And is there a legitimate inspection service plan in place? Similar to the last slide, help them come up with the plan, even if it's a simple one. And if anyone has questions, I have my contact info at the end here, and I have examples I'm happy to share from other areas of the country that have done this. Also ask, who will be conducting post-construction inspections and cleanings? If you're an engineer, it really is in your best interest to ask manufacturers who come to your office with manufactured treatment devices if they have their own service and maintenance team, and then you can work with them on budgeting numbers and putting together a post-construction plan with them directly, or they should be able to recommend someone to you. If none of the above, you should try to network with local people who do this, so you can then offer those to your clients. We know engineers who will inspect for their clients, then work with us to do cleanings, or have local people they use for cleanings. When it's a manufactured treatment device, then they come to us. So there's different avenues you can do this. If you want to be hands-off, just have a resource ready for the owner. If you want to be hands-on, you can get involved in the inspections and things as much as you want, which again, just helps increase awareness. On that final note, I would just say to collaborate. Again, know who's in your area, who can do this, who can help you with this. The manufacturer should be able to help you, point you in the right direction, try to get a contract in place so people aren't left flat-footed when post-construction systems fail. And we know this because we do a lot of things. We have industrial clients we work with, and we do service and maintenance with them. Industrial clients have effluent limits and benchmarks. They don't have the luxury of being, well, we'll go 3 years. They told me I can go 3 years or 5 years before cleaning this. If they fail, they fail, and there's fines and things involved with that. So they're held to a different standard, and because of that, we're very aware of how systems work in the field, both on the municipal side and in that multi-sector industrial general permit side. So by collaborating with people, you're going to learn, okay, if something goes wrong, I don't have the luxury of 2 months to find someone who can clean this. So know who you can work with, whether it's the manufacturer or a maintenance provider. We do other things too. The middle image here, that's a telemetry logger. It's measuring water levels. So things like this can maybe help you see if systems have been in bypass, say, where water levels are at. Things like this, use the best available technology. Don't use what is perceived as easy. Things may be perceived as easy to maintain because people have been cleaning them for 10 years. That doesn't mean it's the best thing out there. It may be the best thing for your application, but it may not be. So the point would be to ask questions and collaborate with different people in the industry to both create awareness and make yourself more aware of what you're working with. And with that, I want to thank everyone for coming. We do have a post-webinar survey. You can be entered to win a $50 Amazon gift card, and we'll be giving out PDH credits to you no later than the end of day tomorrow. So if you wouldn't mind, please fill in the poll. And here is my contact info. Feel free to take a screenshot. You can email me or email back if you received an email notification about the webinar. If you have specific questions or want to see some examples of programs where people have post-construction maintenance plans put in place pre-construction. We also have here the interactive link. So this hyperlink rather is for the interactive maintenance myths. That's 5 of the 7 myths we went over here. It's an interactive that you can look through as well. So there's that for you. And again, thank you, and I will put this survey up right now.